Okay. Good evening. Can you hear me? Okay. Uh, Good. Yeah. What we discussed before that, today is the first paper of first part of SFT, first part of for 2026 A level. Yeah, the paper, standard paper, good paper, right? Not too easy or not too hard. Normal paper. I'll send the paper into group. Manga Athena paper, but it's only photo. I don't have, still I don't have clear. Message చేద్దాం కఠయానికి. Okay. Yeah, the paper is a good paper. Physics part, physics part easy actually this time. Physics part easy and maths part also ICT part easy. Lazy at if you cover all lessons, easily you can get more than 45, right? 45 you can score easy this time paper, right? Next year also same type paper. The thing is the paper is not too easy or too hard. It's medium level paper, standard paper. Okay. The other thing, now you have to start practicing past papers, right? Now, these days, now I'm prepare a past paper book. Right? මම post එකක් දාලා ඇති ඒකේ ඔයාලට our students, class students, I'll send you a book. You only need to pay a printing cost. It's a very large book. I think 500 pages. It's a ලොකු book එකක් එන්නේ with all past papers and answers and marks distribution, everything in one book. I'll send you the price. It's you only need to pay the printing cost, right? I got the paper. Wait, I will share the paper. Okay, this is the today A-level paper 2026. Okay. See, these first few questions very simple. We didn't complete the cell structure lesson yet. But you know, right? Which of the following is found only in plant cell? It's chloroplast. No? What is an example for obligate anaerobic bacteria? Anaerobic Clostridium. බලන්න මේ එයාගේ ආන්සර් තියෙන අය මුල් ටික හරියටම කරලා තියෙනවා මම මෙයාගේ අනිත් ටික බැලුවේ නැහැ. What is the gas that is not typically found in biogas? Biogas production is anaerobic process. Then no oxygen, right? මෙයාගේ හරිය ඔක්කොම. What is the advantage of using of Ceylon satin wood for forestation? Consider following statements regarding arthropods. Arthropoda. Only a few are economically important. All arthropods are invertebrates. Yeah, all are invertebrates. Arthropods are only found in on land, not on land. Arthropods gatham prawns also arthropod, kind of arthropods. Prawns is again. It's wrong. මෙයාගේ හරි. Yeah, only few are economically important. A and B. A and B. 4. එයාගේ එක වැරදි. So a piston cylinder device containing a gas is the reaction energy of reaction between ferrous and oxygen given below. Okay, this is the heat of reaction question. The heat of reaction minus 1648 kilojoules per mole. What's the meaning? Is it exothermic reaction or endothermic reaction? Is it an exothermic reaction or endothermic reaction? The heat of reaction minus when? Exothermic reaction. Then ferrous, oxygen means a burning process. Yeah, burning process. Then ferrous oxide form. Ferrous oxides are formed. What is the amount of total heat released when 10 gram of ferrous react with excess oxygen? The ferrous atomic mass given. Ferrous atomic mass given. Ferrous atomic mass mean 50 molar mass equal 56 joules GMOL minus 1. The number of moles equal mass over molar mass, 10 over 56. Get the number of mole. What's the total heat release? Then total heat take up under the heat of reaction. Heat of reaction equal Q over N, no? Q over N of excess oxygen. We already discussed. Excess oxygen means oxygen is not limited. Then you don't need to consider about oxygen number of moles. එහෙනම් අපි divide කරන්න ඕන කාගෙන්ද? Heat of reaction is given. It is 1648 equal Q is asking the quantity of heat. What is the amount of heat release? Because exothermic reaction, then heat release, right? release Q over N. N key the 10 over 56. Or you can get the decimal value, right? Both okay. Then Q equal cross multiplication. One key then 1648 0 divided by 56. 29,400 බලන්න. හරියටම කරලා තියෙන. මෙයාගේ ආන්සර්ස් තියෙනවා. අද මෙයාගේ මෙයාගේ මම මේ පේපරේ බැලුවේ නැහැ. මෙයාගේ වැඩ කරපු විදිහට මෙයාට තියෙන්න ඕනේ 45 marks වත්. මේ දැනට අපි බලපු වගේ එකයි වැරදි. Only one wrong question. Still you don't know these parts. Biomolecule also didn't complete. Chromatography we discussing, they are very simple things, natural product. Then wala karapu ekin aapu එක දැක්කනේ very simple. This thermochemistry question, right? Very simple. Carbon black, do you know carbon black that we discussing in polymer lesson? Carbon, where we use carbon black? It's a filling material. Do you know in tire production, do you know tire mean are we produce tire by natural rubber or synthesized rubber? Yeah, natural rubber after a process that we call as rubber vulcanization. After vulcanization, as filling material we use carbon black as එක තමයි අර color එකෙන් net එකෙන් and the toughness and less elasticity characteristics given by carbon black. හරියටම හරි. මේ යාගේ answers හරි ඔක්කොම වගේ. එකයි දැන් අහුනේ මට වැරදි. When is a chemical industry selecting machine while focusing 5M concept? 5M concept we discuss in industrial chemistry. 5M mean 5 words, 5 requirements starting letter M, right? That's why we call as 5M. 5M are money, manpower, machine, method and material. They are the 5M concept. Making ahanne, when a chemical industry is selecting a machines while focusing, sorry, when a chemical industry is selecting a machine while focusing on the machine is aspect of 5M, which of least important factor? Even a very common question, no? Again, machine ekak, industry ekak machine ekak, when we select machine, what is the least important factor? The cost we have to consider. Capacity we have to consider. Maintain, essence of maintain, yes, we have to consider. Reliability and accuracy, that one also important, no? Suitability for multiple industries. Yeah, suitable for multiple industries. Aspect of 5M, which of the following least important? Yeah, her reliability and accuracy. Reliability is the main factor, but it is not in 5M concept. 5M concept එකනේ අහන්න, right? එතනනේ ගන්න වෙන්නේ. 5M concept. Which of the most Actually, component found in every industrial sector, every industrial reactor, they all are industrial chemistry questions, right? What's the correct statement regarding detergents? You don't know about detergents. Detergents also industrial chemistry, soap production. Soap production. Soap production. What is the correct statement regarding water quality parameters? Drinking water must have pH of 7. Salinity decrease the conductivity of water. No, increase. Chlorine gas added to fix the water pH value. Not chlorine for disinfection, right? Chlorine for disinfection. Chlorine is used to decrease the COD of water. No, disinfection, not the COD decrease. Water samples with high BOD value have high COD. Yeah, for fifth one correct. BOD mean biological oxygen demand mean the chemical oxygen demand also increasing. මේ ඔයාලා කරලා නැහැ තාම. හරි. මේවා කරලා නැහැ. Yeah, maths questions, I will send this paper. Now, 7:30, we have to start the lesson. I will send this paper. You can try the maths questions. Maths questions very simple. When a wheelchair ramp extends 4 meter horizontally, its rise 1 meter vertically. What is the length of the ramp? Pythagoras. Pythagoras. Okay, let's move into, yeah, make it volume make contain. Volume calculate. Volume of the submarine. They are statistics. Statistic. Yeah, ICT part also very simple. You can try. I'll send the paper. Yeah, this question now you can try. It's mechanical properties. Okay, it's from fluid mechanism. And Kirchhoff law. Final one, Kirchhoff law. Okay, overall the paper is more easy actually. Lessons sticker. If you cover all lessons, definitely you can get more than 40 marks. Right? More than 40 MCQ mean 40 marks. Only within first paper you have S pass. Let's move into lesson. I'll send this paper, right? You can try. Okay, what do you feel after looking this? What do you feel? The actual thing is, up to now, yeah, we have lot more lessons to do. Actually, the most important lessons are future lessons. After kinetic chemistry lessons, we start මේ බලන්න මේ මෙතනින් ඉඳන් තියෙන lessons මම කියන ටිකේ තමයි මේ ඔක්කොම තියෙන්නේ. Yeah, bio lessons, don't worry, we have only 2 bio lessons. Okay, after kinetic chemistry lessons, we have biomolecule, cell structure, industrial chemistry, natural products. Natural products mean extractions, and fluid mechanism and electricity. These 6 lessons are the, I think, more than 80% of MCQ, this MCQ paper. Me hayin tama more than 80% asked, right? After kinetic chemistry, the other thing, no any kinetic chemistry question. I think day after tomorrow, second paper, I told students to go through against kinetic chemistry because next structured part, definitely they will have kinetic chemistry question. Make a kinetic chemistry now. Okay, let's move into less. Okay, what we discussed up to now. Okay, what we discussed the kinetic chemistry. I told the kinetic chemistry is a area that we discussed about the rate of chemical reaction. Rate of chemical reaction. And I told different, we can get some idea about the rate of chemical reactions by different observations, by evidence, right? Air formation, air bubbling, and volume changes, color variations, temperature changes, volume changes, right? Different observations, evidences, we can get some idea about rate of chemical reaction. But I told by this evidence, we can get only some idea or comparison. We can get an numerical value. We can get a numerical value for rate of chemical reaction by this observation. Then we have to calculate the rate of chemical reaction. Okay. Finally, we discussed what is the mechanism of chemical reaction, right? Mechanism of chemical reaction. Again, we have to revise this. Mechanical of chemical reaction. Mechanism, sorry. Mechanism of chemical reaction. Okay, I told any reactants to convert into product. Product mean reactants and product, they have totally different characteristics, right? Reactant characteristics totally different from product, or product characteristic totally different from reactants. Which part is true? You can go to recording. And I will send this paper. Okay, I told reactant product characteristic totally different from reactant. What is the reason for them? What's the reason for that? Why it is difference? I told what's the mechanism of chemical reaction. First, when we mixed two or more reactant, what happened is reactant molecule, in the molecular level, this reactant molecule, they always vibrating. They have some kinetic energy. They always vibrating. Due to their vibrations, these molecule collide each other, right? Due to collisions, this reactant molecule thing, it is A, it's collide with B, C, right? Think it is A is the first reactant, B, C is the second reactant, right? This reactant molecule collide each other. Due to that, they are already available bonds break down. When I will collide with it, they are already available bonds break down and forming new compounds, forming new bonds. It's A and B, new products, new compounds producing, and this place C, right? That we called as chemical reactions. Then what's the mechanism? Reactant molecule collide each other and they are already available bond break down and producing new bond between molecule. Okay, that's the reason for produce new compounds with different characteristics. New compounds with different characteristics, they are the products. They are the products. Right? Finally, I told to complete this process, to effective collisions. Effective collisions mean for these in any collisions to break down bonds and forming new bonds, they should have three main requirements. This collision should complete three main requirements. What are the requirements? One of the requirements. What are the requirements? Reactant molecule collide each other, and collide with proper orientation. Proper orientation, this area very important. That's why I again explain, right? Proper orientation, and they should have sufficient energy. Sufficient energy means they should have energy up to activation energy. The reactant energy, reactant molecule energy level should have up to sufficient energy. That means activation energy. Activation, what's the meaning of activation energy? What's the meaning of activation energy? The definition. Activation energy. What's the meaning of activation energy? Yeah, the minimum energy required. No, you meant the minimum energy needed for reactants, Fatima. The minimum energy requirements for reactants to participate to the reaction. Reactants කියන එක mention වෙනවා. You have to mention කාටද ඕනේ කියන එක. Yes, the minimum energy requirements for reactants to participate to the reaction. To participate to the reaction. The minimum energy requirements of reactants to participate to the reaction, that's the activation energy. That's the activation energy. Sufficient energy means reactant molecule energy level at least fulfill up to activation energy. They should have energy up to activation energy. Proper orientation means the collision orientation. Collision orientation. If it is A collide with C, if it is A collide with other direction, are they produce A and B? No. A and C? No. The reaction not completed, right? Reaction not process to forward, right? Okay, they are the main things we discussed last day. That's the main mechanism of chemical reaction. Okay, after that, finally, I told all these requirements, all these three requirements fulfill collisions. What's the name of it? All these requirements fulfilled collisions. What is the name of that? Nabil, what's the name of them? Requirements fulfill collisions are effective collisions. Very good. Effective collisions. Effective collision. Only effective collisions can make products. Non-effective collisions. Non-effective collision mean at least one of these requirements not completed collisions are not producing products. Can't make products. Okay, they just only collisions, no breakdown bonds or forming new bonds, forming new compounds, right? Are you clear? Matakai, Priyanka? Isuru? Now okay, problem, connection problem? Janidu? Janidu, did you watch the last week class? Okay. Otherwise, you can't understand today. Okay. Finally, we discussed about the rate of chemical reaction. The rate of chemical reaction, the definition, rate of chemical reaction. Rate of chemical reaction. Okay, what's the meaning of rate of chemical reaction? I told always if you got chemical reaction, reactants, what happened to the reactant amount? Reactant convert into product, reactant convert into products. What happened to the reactant amount? Reactant amount, reactant molecule amount is gradually decreasing. Yes, gradually decreasing. The reactant amount gradually decreasing. Yeah, reducing. Product number of moles gradually increasing. Then number of moles, number of reactants mole in unit volume of reactants decreasing. Then we can say the concentration of reactants decreasing. What happened to the number of moles in unit volume of products? The unit volume number of moles of unit volume of products, it is gradually increasing. The product concentration gradually increasing, reactant concentration gradually decreasing. Then how we can define the rate of chemical reaction? Capital R. The rate of chemical reaction equal. How we can define? The concentration change per unit time. The concentration change per unit time of reactants or product. That's the meaning of rate, right? That is speed. The speed. The concentration change. The concentration change. That means the rate of chemical reaction equal the concentration change. Concentration change per unit time. Per unit time means divide by time. Divide by time. The concentration change of reactants or products within 1 second. That's the meaning of rate of chemical reaction. Then what is the unit of rate of chemical reaction? What's a unit? Unit of rate of chemical reaction. What's the unit of rate of chemical reactions? Yes, moles per cubic decimeter. Moles per cubic decimeter. It's a concentration unit per seconds. Per second. Per second. Per seconds. Moles per cubic decimeter per second. Still, I revising last week lesson, right? Tamkaran last week. Okay. The final thing I told, think within 1 second. If you got initially number of moles, reactant number of moles 10, right? Initially reactant number of moles 10. I told gradually what happened in next second, it is less than 10 or greater than 10. The concentration, reactant concentration, initially it is 10. It is less than 10 or greater than 10. Okay, that one, the rate of chemical reaction equal the concentration change within unit time. Okay, I ask you, initially reactants concentration 10, right? After some time, after think within 2 seconds, after 2 seconds, the concentration 10 or greater than 10 or less than 10. It is less than 10. It is decreased to up to 4, right? But what happened to the product concentration? Product concentration increase. Think initially it is 2. After 2 seconds, it is increased up to 8 or increasing. It's greater. Yeah, increasing. The concentration increasing. Right. Now, If you got reactant decaying rate means reactants always concentration decreasing, decaying, right? Breakdown. If you got reactant decaying rate, it's always plus value or minus value. The concentration change means final concentration minus initial concentration. Then it is 4 minus 10 over 2 seconds time, right? Then the rate of the decaying rate always for reactant it is minus value. For reactants it is minus value, right? If you got product, but if you got products, products no problem. 8 minus final concentration minus initial concentration. This concentration change divided by time. The concentration change of unit time of products. It is always plus value. Why? 8 minus 2 divided by 2, right? 8 minus 2 divided by 2. 2 mean time, right? I got as 2 seconds, within 2 seconds. Right? It's 6 over 2. It is 3. It's 3. It's plus value. Then product producing rate always plus value. Reactant decaying rate always minus value. Okay. This is the summary of last week class. Do you have any doubt? Any doubt? Okay, finally, okay, again we discuss with calculation this reactant decaying rate and product producing rate and final the average rate of chemical reactions we calculate in the final part, right? Still you should have simple idea. If you got reactant decaying rate, it's always decrease in the concentration, therefore it is minus value. Product producing rate, since it is increasing the concentration, it's positive value, right? Positive value and minus value. And you should have some idea what's the definition of rate of chemical reaction, how we can define the concentration change of reactants or product within unit time. The unit is moles per cubic decimeter per second. Moles per cubic decimeter per second. Okay, finally, I told what are the factors affect on rate of chemical reaction. Factors affect on rate of chemical reaction. Okay, what are the factors affect on rate of chemical reaction? I told for easy study, we can divide the factors affect on rate of chemical reactions into two categories: direct factors or main factors, direct factors and indirect factors, or extra factors, indirect factors. Okay, what are the direct factors? Direct factors only 4. What are the direct factors? What are the direct factors? Yeah, the temperature good. Very important theory. Temperature, reactant concentration good, reactant concentration, reactant concentration, reactant concentration. Third one, catalysts. Fourth one, Reactant contact surface area. Good. Reactant contact surface area. Surface area. Okay, they are the main factors affect on the rate of chemical reaction. It's only four, right? No more than four. It's only four factors mainly affect on directly affect on rate of chemical reaction. Okay, what are the other factors? What are the extra factors? Yeah, light energy, pressure, yes, pressure, pH value, UV radiations, yes, UV radiations. Okay, these factors, heavy metals, yes, these factors mean these factors mean if we change the factor, as example, if you conduct chemical reactions in light condition and dark conditions, okay, it should have difference, right? Then we can say light is a factor effect on rate of chemical reactions, right? Light condition and dark conditions, if you conduct same experiment, right? Same experiment and other all conditions constant, while keeping other all conditions constant, light condition and dark condition, then it should have considerable difference. But if you, it's only very slight difference, not considerable difference. That's why we call light is a indirect factor. That's a factor that's effect on the rate of chemical reactions, but it's not too much. It's slightly effect. I got pressure also same. If you did same reactions, high pressure condition and low pressure condition, no considerable difference, right? But they should have difference, but it's not considerable than like them. But if you conduct same chemical reactions in 30 Celsius and 60 Celsius, it has a considerable difference. I got, that's why we call they are direct factors. Understood? Direct factors and indirect factors. Okay. Okay, up to this point, last week we discussed. Okay, today our first topic, the temperature effect to the rate of chemical reaction. Give me a second. Okay, sorry. Okay, what do you think? Okay, when increasing the temperature of any reactant mixture, what happened? What happened to the rate of chemical reaction? It is increasing or decreasing? While increasing the temperature of any chemical reaction, the rate of chemical reaction or the speed of chemical reaction increasing or decreasing? Yeah, definitely it is increasing for any chemical reaction. All kind of chemical reactions with temperature, the rate of chemical reaction, the speed is increasing. the speed is increasing. You know, exothermic chemical reactions, they naturally, during the reactions, they produce some heat. Due to that, what happened to the system? Inside the system, heating. It's a huge in industrial process. Industrial, I mean, we discussing industrial chemistry. In the industrial chemistry, that's a huge problem. Huge problem being like this. We can't keep the production process stable, because if we then think it normally in industry chemistry, the chemical reaction take place container that we called as reactor, right? අර paper එකේ තිබ්බ නේද chemical මේ reactor එකක් ගැන අහලා. This one another very simple question. I may miss this. That one also thermochemistry. Can you send me the answer? A piston cylinder device contain a gas is perfectly sealed. If the cylinder walls allow heat transfer to the system. This system is an open system, a partially open system, a closed system, an isolated system, and independent system. What's the type of system? Yeah, they are very simple. A closed system. මේක react එකක් ගැන තිබ්බනේ. This one. But the most essential component found in every industrial reactor. Every industrial reactor, the reactor mean it's a container which the chemical reaction is take place. Chemical reaction take place. Container is the chemical reaction take place. Container is the reactor. Chemical reactor. What is the most essential component? What do you think? What's the most theory in general knowledge? What's the most essential component found in every industrial reactor? Mixture, pressure gauge, heater, cooling system, gas product, remover. What do you think? No, we have a cooling system required for exothermic reactions only. Make a every industrial reactor. In industrially, we not perform on we not perform only exothermic reactions. We doing endothermic reactions as well. Then no cooling system always required. If it is heat generate reaction, cooling system required. But the question is every reactor. I got the point behind it. Yeah, the pressure gauge. Yeah, pressure gauge is not a compulsory. No, Janindu, every reaction not producing gas products. Sometimes products only solid. They no required gas removal. The question is every. Yeah, every reactor what is the requirement? දැන් ඔයාලා කරේ එක. Every chemical reactions, the requirement is reactant molecule collide each other. For collisions, what is the main requirement? Mixing. මේක මික්ස් වුණොත් තමා අනිත් ඔක්කොම වෙන්නේ. Cooling system requirements, pressure requirements, heater or gas product remover, all are. The first thing is reaction take place. For reaction take place, reaction molecule collide each other. That's a requirement. Then the mixing is the crucial thing. Okay, we discussing about මේකේ එකක් ඇවිත් තියෙනවානේ kinetic chemistry. This question, this is not kinetic chemistry, it's industry chemistry. Then no kinetic chemistry question. Yeah, no kinetic chemistry question. Then I hope one structured is a full from kinetic chemistry, including rate of chemical reaction calculations. Yeah, it will be a good question. Hi. Okay, these are, think it is chemical reactor. The container take place the chemical reaction, right? Think an exothermic reaction take place in the container. A plus B, it is produced AB2. Reactants convert to product, it is exothermic. Then what happened to the internal temperature? Internal temperature gradually increasing, right? Gradually increasing. Think initially it is 20 Celsius. After 1 minute, it is 22 Celsius. Again, 1 minute, it is 24, right? Gradually increasing. Then what happened to the rate of chemical reaction also? The rate of chemical reaction also getting increase with temperature, right? Due to that, in this type reactions, exothermic reaction in industrially, exothermic reactions, while take place exothermic reactions, it is very difficult to maintain rate. That's why we have to add cooling systems and so on different mechanisms to control this temperature, right? Okay. However, every chemical reactions, when increasing the temperature, the speed, this rate of chemical reaction is increasing. Okay, but not all chemical reactions continuously increase, right? If you got normal chemical reactions, MCQ වල අහන්න. If you got normal chemical reaction, it's increasing like this. Normal reaction means acid-base reaction, acid metal reactions, metal water reactions, like normal laboratory reactions. It's temperature and the rate of reaction, right? Gradually increasing, temperature increasing, the rate of reaction also gradually increasing. It's not a straight line. It's as a curve, it is gradually increasing, right, with temperature. Okay, they are normal reactions, normal laboratory reactions. But if you got biochemical reactions, what's the meaning of biochemical reactions? What's the meaning of biochemical reactions? What's the meaning of biochemical reactions? With me? What are the biochemical reactions? Biochemical reactions mean chemical reactions take place in biological structure inside organisms, right? The respiration is a biochemical reaction. The food digestion is a biochemical reaction. Okay, okay. With me, Safa, I'll show you again. Wait. Yeah, the chemical reactions take place inside living cells. Good. Inside living cells. Cellular respiration, the photosynthesis. Okay, they are the biochemical reactions. Okay, what do you think the behavior of the rate of chemical reactions with temperature of this biochemical reaction? Biochemical reaction. Okay, this is the temperature and this is the rate of chemical reaction. Rate of chemical reaction. Safa, do you have this tube? Safa? You have. Okay. Okay. Biochemical reactions. Biochemical reactions is like this. Okay. In normal temperature, in very low temperatures, right? Now temperature is very low, right? This level. Very low temperatures, their rate is very low. But with increase in the temperature, the rate gradually increasing. Gradually increasing. Right? Rate gradually increasing. But at a certain level, it's reached to the peak point like this. And after this point, normally this temperature 40 Celsius for living cells. Inside living cells, 40 Celsius. After 40 Celsius, again the rate decreasing. Are you clear? Again rate decreasing, not increasing like this, not continue increasing like this as normal reaction, right? In normal reactions, it's continually increasing, right? Like this. Normal reactions continue increasing. Understood? But biochemical reactions, they have at a certain limit, normal around 40 Celsius, they reach the rate reach to the peak point, maximum rate, and gradually decreasing. Understood, Nabil? Nabil? Good. Gradually increase with temperature and reach to peak point, and after 40 Celsius, again slow down. Again slow down. Okay, what do you think about explosive reactions? What are the examples for explosive reactions? Explosive reactions mean, what are the examples? High speed reactions, I told last week. High speed reactions, explosive reactions, explosive reactions. You can Pupuraneva. Bombs, right? Bombs. Okay, if you got explosive reactions, they are temperature, temperature, and the rate of chemical reaction, the rate of chemical reaction. Yeah, a fuel mixture combustion, yes, inside the engine, right? That one also explosive reaction. Good. Okay, these explosive reactions like this. With temperature increase, the rate gradually increase, But at a certain level, at a certain temperature level, the rate increase in lightness. Suddenly increase within few seconds, the reaction take place with high speed, with very fast speed. I got. Okay, they are the explosive reactions, high speed reactions. Inside engine, the petrol wave, air-fuel mixture burning is explosive reaction. Good. Bombs also, bombs also this type reactions had. Okay. Draw these three graphs. It's normal reactions, biochemical reactions, and explosive reactions. Okay, first draw normal reactions. Biochemical reactions. Explosion reactions. Complete. Zero. Are you done? Okay. Dulen, Hamid. Johnny. Okay. Hi. Okay. Now summarize what we discussed up to now. Okay, I told all chemical reactions with temperature, the rate of chemical reaction increases. But according to the type of chemical reactions, their behaviors changing, right? If you got biochemical reactions after peak level, it's again decreasing. Explosive reactions after a certain level, it's rapidly increasing, right? Normal reactions gradually increasing with temperature. Okay, now let's see the effect of temperature. How practically express the temperature effect to the rate of chemical reaction. Okay, it's a very simple, very simple practical. Very simple experiment. Okay, you can draw this diagram with me. Okay, it's a test tube. Same size, another test tube. Aqueous HCl solution. HCl aqueous solution. HCl solution kya naam? HCl solution. That's been diluted HCl, right? Diluted, not 100%. Aqueous mean with water, right? Water solution. Water mix HCl. Think both test tube filled with 500 milliliter of 500 milliliter of HCl, 500 milliliter of HCl. Okay, then what you can say about the concentration of these two HCl solutions, A and B? Think it is A test tube, B test tube. Okay, what do you think about the concentration of reactant concentration? Is it same or different? The reactant concentration. I got HCl solution, same solution, added same volume. Same volume. How about HCl concentration of A and B? Same or different? That's I want. How it is different, mate? It's same solution. Same HCl solution added same volume. Then same concentration. Right. Same concentration. Now add 5 gram of magnesium parts to both test tube. 5 gram of magnesium, right? 5 gram of magnesium strip, magnesium solid part, right? 5 gram of magnesium strip, magnesium part, right? 5 gram of magnesium part. Okay, now what are the factors main factors affect on rate of chemical reactions? Kian? Temperature, reactant concentration, catalyst, and physical state, mean contact surface area. Contact surface area. Okay, now how about the concentration of both solutions? Met me. Concentration of A and B, both solutions, same or difference? Same. Then the concentration is constant. Concentration constant. Did we add any catalyst for both any test tube? Did you use any catalyst? No, then catalyst same. Okay, what happened to the contact surface area? At both same size magnesium particles, magnesium strip. Then contact surface area also same, right? Contact surface area also same. Okay, what is the purpose of this experiment? To check the effect of temperature. To check the effect of temperature, this is a rule, right? Keep all other factors constant and only change the temperature. To change the temperature, I'll use a I am going to use the water bath, right? 2 water baths. Separate water bath for 2 test tubes, right? First, this is water. The first, right? They are water, right? First, A test tube, I'll keep in 30 Celsius water, 30 Celsius water bath, and 30 Celsius water bath. And second, B test tube, keep 60 Celsius water bath. 60 Celsius water bath. Okay, this is a practical. I clear. I'll explain again, right? First, prepare a solution of HCl and add same volume into two same size test tube, right? Then concentration same. Then adding same size two magnesium strips and place two water baths. Separate water bath with different temperature. Okay, what you can see the observation here. What's the observation? Okay, magnesium react with HCl. Then what we can get the observation? What are the observations? We can see the magnesium part is decaying, right? Magnesium part is decaying, breakdown. And what are the other clear observation? What's a clear observation? Most clear observation? Yeah. Others? What are the products? Magnesium and HCl. What are the products? Yeah, very good. Gas bubbling. Yes. It's producing magnesium chloride, MgCl2, and hydrogen gas. Hydrogen gas. Yes. Yeah, it's releasing hydrogen gas. Gas means we can see air bubbling. Air bubbling. Okay, this is the air bubbling rate of, I told we can get some idea about, we can get some comparison about rate of chemical reactions by these observations. Okay, this 30 Celsius A test tube, magnesium part slowly decaying, slowly break down, and slow air bubbling rate. But 60-degree pan B test tube, it's highly decomposition, highly decaying, and comparatively high air bubbling rate, like this. You can observe like this. Okay, this is a difference. Since other all factors, since concentration same, catalyst same, contact surface area same, only temperature is a different factor, right? Then we can decide the temperature increase, the rate of chemical reaction is increasing with temperature. I clear? The rate of chemical reaction is increasing with temperature increase. Okay, clearly draw this. Clearly draw this. So what's the purpose of keep separate water bath? confirm different temperature, right? Provide different temperature, right? Provide different temperature. Complete. Okay. Okay, write down first point here. Select. First step, select two same size test tubes and label as A and B. Second point, at same volume of HCl, aqueous solution aqueous solution at same volume of HCl aqueous solution with same concentration into both test tube. Into both test tube, right? Third step, add same size solid magnesium particles, Mg particles, into both test tubes and both test tubes and a test tube. No, get as another point. No need and. That's the third point. At same size solid magnesium particles into both test tube. Both test tube. Both test tube. Fourth one, A test tube second. Sorry. A test tube place 30 Celsius water bath and B test tube place in 60 Celsius water bath. Final steps. Get the observation of the difference of air bubbling speed. Okay, observation. Observation. It's a simple experiment, right? Observation that you already know. Observation. Okay, what is observation? B tube, air bubbling speed, greater than the මෙහෙම ලියන්න දෙන්නේ exam එකේදී. In exam not asking to write methods observation, they not asking, right? B test tube air bubbling speed greater than the A test tube. A test tube. A test tube. Right? Finally, conclusion. Since all other factors constant, yeah, right? That's why we can conclude, right? That's why we can get an result or final summary, final result, final decision. Since all other factors constant, or all other factors constant, only temperature is the difference, right? Since all other factors constant, when increasing the temperature, the rate of reaction increasing. When increasing the temperature, the rate of reaction increasing. Okay, sorry. Complete. This is a very simple experiment, right? First, get two same size test tubes and add same concentration HCl, same volume, and add same size two magnesium strips and place different water bath with different temperature, right? With different temperature. Then get the observation A test tube, sorry, B test tube, 60 Celsius test tube air bubbling speed greater than the A test tube, right? 30 Celsius test tube. Then we can decide, since other all factors, concentration reactant concentration same, contact surface area same, we didn't use any catalyst. Then since other all factors constant, we can, like, temperature increase. The temperature is the factor increase the rate of chemical reaction of this chemical reaction. Temperature is a factor. Temperature is a factor. Temperature is factor. Okay, explain the effect of temperature. Okay, that's the in the next part we have to explain the rate of uh, effect of temperature to the rate of chemical reaction. How increase the rate of chemical reactions? Now you already know experimentally. You know, when increase in the temperature, the rate of chemical reaction, the reaction speed is increasing. Now, in this part, you have to explain how it is increasing, what happened in molecular level, what happened. Now, you already know to take place reaction, what are the requirements? Reactant molecule collide and bond breakdown and forming new bonds, right? That's when effective collisions are the requirements. With temperature, what happened to the molecule? How increase the rate of chemical reaction? What do you think? What do you think? Any idea? Any idea? Yeah, very good. Good, good. Good you meant. Yeah, that's the point. While increasing the temperature, what happened? Molecule vibrations, molecule kinetic energy increasing. Molecule kinetic energy increasing. Right? When the increase in temperature, the molecule kinetic energy increases. Right? Actually, opposite side, temperature mean molecule kinetic energy. Right? But we can't measure the molecule kinetic energy, right? It's in molecular level. We can observe only temperature change. Okay, therefore, now okay with me? Okay. When increase in the temperature, yeah, when increase in the temperature, the molecule vibrations, molecule kinetic energy increasing like this. Think it's reactants. They are reactants, freely available reactants now, right? Freely available reactants, reactant molecule. Now they should have some kinetic energy. They have some kinetic energy and they have some vibration limit, right? They colliding and convert into product. Collide. Some collisions are effective, therefore they produce product. If not effective, they are not producing. Again, collide and effective collisions produce product, convert to products, and so on, right? Now, when increasing the temperature, what happened to this molecule? Their molecule vibrations increasing, molecule kinetic energy increasing, increase molecule kinetic energy, temperature increasing. Due to that, molecule kinetic energy, vibrations increasing. Due to that, what happened? Molecule vibrations increasing mean molecule collisions increasing. Collisions increase, effective collisions also increasing, right? Think initial, in normal temperature, number of collisions 100, right? Number of collisions 100. Think effective collisions 70. 70 effective collisions, right? 30 non-effective collisions. Then 70 products forming, right? But when increasing the temperature, think it is increase up to 200 collisions. Then what happened to effective collisions? Effective collisions also increased up to 140. Example, right? හරියටම double වෙන්නේ but 140 increasing. The effective collisions also increasing when increasing the collisions. Okay, that's a reason. Understood? Vihanga? increase effective collisions with temperature molecular collisions. Okay, not only that, with temperature there is another reason. තව reason එකක් තියෙනවා. හරි මේ බලන්න. I told reactant molecule to participate to the reaction. This reactant molecule should have sufficient energy level, right? Sufficient energy level. Think it is A molecule, B molecule, C molecule, and for chemical reaction activation energy. Activation energy means the minimum energy level. The minimum energy level 10 joules. A contain initially, right? Initially A contain 8 joules, 9 joules, and C contain 10 joules. Then who can only participate to the reaction among A, B, and C? කාට විතරයිද participate වෙන්න පුළුවන්? Only C. No, Janidu. To participate to the reaction, the reactant molecule energy level exceed or up to the activation energy. That's a requirement. ඒ කියන්නේ A level එකටවත් තියෙන්න ඕන. I got Janet. That's a third requirement. Right? Then only C can participate to the reaction. But A and B, if they collide with other molecules, they cannot participate to the reaction. They are not effective. The reason they don't have sufficient energy level. But when increasing the temperature, while increasing the temperature, as a result of increasing temperature, they're producing some heat, right? They produce some heat, or we have to supply heat energy. Okay, then what happened to the kinetic energy of molecule? Energy level also increase. Energy level increase. Energy level increase means අපි හිතමු ඔක්කොගෙම every molecule energy level increase by 1 as example 9 joule, 10 joules, and 11 joule. Right, after increasing the temperature. Then energy level increase. What happened? The participate number of molecules. B and C both can participate to the reaction. B and C both can make effective collisions. I got, when increasing the temperature, the molecule energy level also increasing. As a result of that, effective collisions, number of molecule exceed activation energy is increasing. I got this. It's very, very important. Activation energy is same, right? Not activation energy changing, right? Activation energy same. When increasing temperature, the molecular energy level is increasing. Molecular energy level එක වැඩි වෙනවා. The molecular energy level is increasing. Due to that, activation energy exceed number of molecule increasing. I got the point. Maybe initially activation energy exceed a number of molecules. For example, it's only 1. But if increasing the temperature, it's not 2. I got number of molecule exceed the activation energy is increasing. Clear, Isuru? This theory very, very important, right? Okay. Any doubt, Fatima? Good. Okay. Let's move into the first point. Okay, first point. When increase the temperature, the kinetic energy of molecules is increasing. Due to that, molecule, the vibration increase and number of molecule collisions, number of molecule collisions increasing. So effective collision increasing. This is a one reason for increase the rate of chemical reaction with temperature. Increase the rate of chemical reaction with temperature. Note down. This is the reason for. This is one reason, not the only one. It's only one reason. It's just one. Okay, complete. Second point. Second point. When increasing the temperature, molecule energy level is increasing. Then Yeah, this is the most important point. Then number of molecule, not the activation energy change, right? Activation energy same. The number of molecule exceed the activation energy. Number of molecule exceed the activation energy. Is increasing. That means sufficient energy fulfilled, number of molecules increasing, right? Initially 30 Celsius temperature, activation energy, previous example, right? 30 Celsius temperature, number of molecule exceed activation energy, think 1000. But if we increase to 60 Celsius, it is increased to 1500, 1800, like this, right? It's increased number of molecule exceed activation energy. This is, and another reason, or second reason, to increase the rate of chemical reaction with temperature. With temperature. This is another reason to increase the rate of chemical reaction with temperature. Okay, complete the final line clear, Nani. Exceed the activation energy is increasing. This is another reason to increase the rate of chemical reactions with temperature. Right, Mariam? Complete. You have another space. මේ page එක තිබෙනවා මම දැක්කා. Okay, let's move into the second main factor effect on rate of chemical reaction, the concentration. The concentration mean actually the reactant concentration, not the product concentration, reactant concentration. Reactant concentration. Okay, what do you think when increasing the rate of chemical react, when increasing the concentration, what happened to the rate of chemical reaction? It is increasing or decreasing? Reactant concentration? Concentration of reactants What do you think? Yeah, the rate of chemical reaction also always increasing. Always increasing. Okay, let's move into the practical directly because and if you got the a graph, its concentration and rate, that one also same as normal reaction effect of temperature, gradually increasing. Every reactions, biochemical reaction, so no indifference, concentration increase, it is gradually increasing, right? Gradually increasing. All right, let's move into the experiment. The same experiment explained in your syllabus. Get two same size test tube, two same size test tube. Label as A and B. Now adding different concentration of HCl, right? Think it is 0.4 mol dm minus 3, 200 milliliter HCl. For B test tube, adding 0.8 mol dm minus 3, 200, same volume HCl, right? Different HCl concentration, right? Same as previous, adding two magnesium particles with same size, with same contact surface area and with same mass, same size, magnesium part, right? And the concentration difference, contact surface area same, we're not going to use catalyst for any test tube. Then what is the other factor we need to keep constant? What's the other factor? For second practical, I want to show the concentration effect. Then what is the other factor need to maintain constant? Yeah, the temperature. How to keep temperature constant? How we can keep temperature constant? Any idea? Very good. We have to use water bath. The Mihima bath approximately it's same, but we have to show that same temperature. Yeah, we have to use a water bath. Now both tubes place in a same water bath. Yes. Right. Water. Okay. Draw this. Now it's very simple practice. Okay, complete. Ah, okay, write down. First step, select two same size test tubes. So, but if those are same, in which was the moles level was difference? If those are same, in which was the moles level was difference? Is it HCl concentration? Yeah, I couldn't understand you. If those are same, mean magnesium same. Yeah, the concentration is different. Reactant concentration difference. Ah, I forgot. What is our observation? What's the observation? Yeah, what's the observation? Yeah, the A test tube, it's that one also release gas, hydrogen gas. Yeah, slowly release air bubbles. Slowly forming air bubbles. But B test tube, it's highly, it is greater than A tube, like this. Ah, that one also you have to mention. The observation. The thing you need to understand, if you need to show the effect of factor, other all factors need to be constant, right? Temperature same, concentration only different factor now. That's why we can decide the B test tube rate of reaction increase due to concentration change. Concentration change. Select two same size test tubes and label as A and B. Same size, two magnesium strips, magnesium particles, parts into both test tubes. Both test tubes. Third one, both test tubes place in a same water bath same water bath to confirm, to make sure provide same temperature. Same temperature, right? Get the observation of the change the rate of air bubbling speed. This is a method, right? This is a method. Okay, next observation. Observation. The air bubbling speed of a test tube. A or B. B is greater. B test tube is greater than A test tube. The air bubbling speed of B test tube is greater than the A test tube. Final conclusion. 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 Since other all factors constant, other all factors constant, the concentration increase the rate of chemical reaction increasing, right? When the concentration increase, the rate of chemical reaction increasing. That's the final conclusion. The thing is, other all factors, other all main factors affect on rate of chemical reaction is keep constant, right? That's why we can decide the concentration is a factor affect to the rate change, right? Reaction rate change. Okay, complete, Sumit? Okay. Okay, now you have to explain how to affect the concentration to the rate of chemical reactions in molecular level. What is the effect in molecular level? මොකද වෙන්නේ? Okay, it is very simple. When increasing the reactant concentration mean what happened? Yeah, the number of molecules in a unit volume. Yeah, the concentration mean number of molecule or amount of matters in unit volumes. The concentration increase mean the amount of molecules in a unit volume is increasing, right? In a unit volume, this type unit volume, the amount of matters increasing. Then what happened? There are collisions. Collisions increasing due to that. Now molecules are very close. Due to that, molecule collisions, number of collisions increasing, right? That is the reason for increased rate of chemical reaction. Then effective collisions increase. I got very simple. The concentration definition, by the definition of concentration, you can get the idea, no? The concentration means the amount of matters, the amount of number of moles in a unit volume, right? Then when increasing the amount of matter in unit volume, they are very close. Then collisions increasing, very easy to collide them. Then effective collisions also increasing. That's the reason for increased rate of chemical reaction. Okay, write down final point. While increasing the concentration the number of molecule, the amount of molecule, the amount of molecule in a unit volume is increasing. The amount of molecule in a unit volume is increasing. Due to that, molecules close to each other. Therefore, Therefore, molecule collision ability, collision possibility කියලා collision possibility is increasing. Possibility is increasing. This lesson actually you don't need to remember anything, right? You don't need to by heart anything. Very simple concept. Only few concepts, same pattern, right? Therefore, the molecule collision possibility is increasing. Then effective collisions also increasing. This is the reason for increase the rate of chemical reaction. This is the reason for increase the rate of chemical reaction with concentration. This is the reason for increase the rate of chemical reaction with concentration. Okay, 2 factors completed. 2 factors completed. Okay, today 19th, no? Yeah, next week we can't complete this lesson because we have another 2 factors, and next 2 factors very simple. The other one is catalyst part easy, and yeah, next week we can complete up to expression part. Yeah, then the next week is the most important part, rate of chemical reaction expression, and final week after next week, after next week, 23rd also we can conduct class. Only for this week, let's do Sunday also. Then we can complete this lesson within this month. Otherwise, we have to get another day next month. Okay, let's do Sunday morning. You are free now? Still you free Sunday? Yes or no? Yeah. Okay, then let's do as extra class on Sunday morning. Sunday morning to complete up to expressions, chemical reaction expressions, rate of chemical reaction expressions. And let's do Sunday and Wednesday both. Then we can complete within this month, kinetic chemistry within this month. Then next month we can start new lesson, biomolecule. Morning, sir. 8:30. 8:30 to 11. So are you free? Last week we couldn't because due to 2026 guys paper discussion. Okay, this week no problems, we can conduct. Okay, then Sunday morning and 26 Wednesday evening you have class, that then the kinetic chemistry completed. We need only 2 days. Okay, these two factors and final part, expression part. Expression for rate of chemical reaction. This is the most important part, right? This time no questions. Therefore, definitely next year MCQ paper you have expression question. Definitely, because this time no questions. But last time also there is a question, right? 2025 A level also there is expression question, rate of chemical reaction expression question. Okay, by this comparing past paper also you can get some idea about your paper, right? I will explain in the revision classes, right? You can get more information. You can find more information about your paper. Product compare karla balawama, analyze karla balawama. You can find more things. Okay, then let's meet on next Sunday morning with expression part, final part and expression part. Okay, good night. Goodbye.